Hello, I'm Varun, and I've been developing software for last 8 years, and I've worked in many fan companies. Today in this video, we'll be talking about message broker and queues. Message broker and queues, they're extremely important for your web architecture, especially if it's asynchronous one. There are many message queues and web brokers available in the market, like Apache Kafka, RabbitMQ, Amazon Kinesis, Redis PubSub, and whatnot. And you need to decide which one is suitable for your application. How do you pick that? I'll be talking about 6 important factors that you need to consider before picking your message broker for your use case in production. So let's dive into it. Okay, so let's talk about why message broker or a queue is needed. Let's take an example. Assume that you are going to a pizza shop where you'll order pizza. This is you, peak animation moment here. This is the person who is taking the order. Don't go by the scale, just try to understand the concept here. And you are in front of the queue. So what here we have two options. This is you can say to the pizza person that I need a pizza. And that pizza person will go and prepare the pizza. Either you can stay here and hog the queue. Stay and wait for pizza. Or you can go sit at your table and they will inform you when your pizza is ready. This stay and wait is called sync processing, and this is called async processing. Now let's understand this in terms of our web applications. See this. Here is the user, he is putting an order request to an order service, and response is given to the user immediately that your order is placed. And this message service, this order service is putting this message in a queue which will be consumed by multiple services like the shipment service, analytics service, and supplier service. Here we are taking an example of Amazon architecture. You have put an order request to the order service and you immediately get a response that your order has been placed. Now, behind the scenes, this order service is putting your order request to a message queue or broker, and that particular order will be consumed by multiple services. In this case, shipment service. The service will decide how to ship your order. Analytics service who's taking care of how many orders have been placed. The supplier service, which will update the inventory that this order has been placed and whether more orders are needed or whatnot. So this one message that has been put to the queue by this order service is being consumed by shipment, analytics, and supplier service. In this case, if you see, this is our producer, and all these three are our consumers. This is a typical architecture of a message queue and message broker. Okay, now let's understand what are the parameters that I was talking about. First is data retrieval, push versus pull. What is push versus pull? So in some systems, your consumers subscribe to the queue and they periodically poll whether the message is there or not. Let's understand this in this case. Let's say we are talking about pull model. So in pull model, the shipment service will go to the queue and ask whether something is there for me to consume. And it will keep asking this, let's say in intervals of 5 seconds, 10 seconds, or some n seconds interval. This method is called polling. In push model, whenever a new message is here, this queue itself will take care of that it delivers that particular message to all the consumers who have subscribed to it. So these are some generic concepts of push versus pull data retrieval. Take the example of Kafka. Kafka is a pull-based system. All the consumers who have subscribed to that particular queue will periodically poll that queue and wait for the message. If message is there, they will get it. If it's not there, they'll just keep on polling till the message is present in the queue. But in contrast, if you see Redis PubSub, it is a pure push model, immediately delivering message to the subscribers. As soon as something is there in the queue, it will immediately be delivered to the consumers, and that responsibility is on the PubSub. Why push versus pull matters to you? If your application is very time critical and it needs data in very low latency, you will go for a push based model like Redis PubSub. If it is not so time critical, you might go for Apache Kafka or Amazon Kinesis, a pull based model. Several of these applications support both. So you need to evaluate that when you are selecting a system. Persistence. This is also very important factor while deciding which message queue you should select. For example, in this case, if your order one is present here in the queue and shipment receives it, at that time analytics service was not up. Let's say it was down or something. This message is missed and has not reached analytics service. Does that cause an impact to your system? If yes, you would need a message queue that contains some persistence to it, so that when analytics service comes back up, it can go and pick the O1 order from the queue. Now, for different systems, this persistence can be different. Like Apache Kafka, it can be 7 days, 30 days, or infinite. You can set it up. For Redis PubSub, I think it is no persistence by default. You can tweak it for now. All these things change time to time, so you need to check whether Redis PubSub has offered this functionality or not. But as far as I know, right now there is nothing as persistence in Redis PubSub. So this is another important factor that you need to consider. Next thing is ordering guarantees. When you put 2, 3 orders in the queue, do you want the queue to maintain that order? That O1 should come first, O2 should come later, and then O3 in the same order that they were put in the queue. So this varies from queue to queue. Kafka has partitions within the queue. So Kafka guarantees that your messages will be in order as long as they are in the same partition. If they are not in the same partition, order is not guaranteed. Similar goes for Kinesis. Kinesis has many shards. As long as messages are in one shard, they will be in order. Otherwise, they won't be in order. So you need to evaluate these for different systems. I have put a small summary of these here, but you need to evaluate on your end as well. Next is storage type. Different messaging systems offer different storage. Like Apache Kafka offers disk-based storage, and Redis PubSub offers in-memory storage. Disk-based storage do offer a larger persistence, like they can store your messages for 1 year or more or infinite in case of Kafka, but they will be a bit slower. Redis PubSub, on the other hand, is pure in memory, so it will be much faster. Now let's talk about delivery guarantees. Apache Kafka, RabbitMQ, and IBM MQ offer at least once guarantee, meaning your message will be delivered to a consumer at least once for sure. It will not be missed. It can be delivered multiple times, but it will be delivered at least once. So if you have a system where you need stronger consistencies, these are your candidates. But on the other hand, Redis PubSub offers at most once guarantee, meaning it can be delivered at most once or it may be missed. So when will you need Redis PubSub? With Redis PubSub, you will make sure that some service is giving it persistent storage or some service is taking care of your message deliveries or your use cases such that you don't care about delivering the message for sure. So these are the factors in terms of delivery guarantees you need to consider. Scalability. Your systems are bound to scale. They will scale for sure. So you need to know whatever broker message queue you are choosing, how is it going to scale? And you need to design your architecture accordingly from the starting. In Apache Kafka, you have many partitions that you can increase. In Amazon Kinesis, you have shards you can increase. In shards also, you have a limit of input and output that decides the cost AWS is charging you. So you need to consider that. In the Redis PubSub, it is limited by memory. You can vertically scale, give it more RAM, and it will work for you. You can pick the cluster mode of Redis PubSub as well for higher availability. So these are the things you need to consider in terms of scalability. So these were the few things that you needed to consider while picking your message broker or queue. I hope you like this video. I hope you find some value in this. If you have some suggestions for me, please put it down in the comments. If you like this video, please give it a like. I'll see you in the next video. Till then, bye.